All right, guys, test review number 18. Let's knock this thing out. Number 1 says find all the zeros. We always start out by making our list. This list is only going to have 1, 2, and 4 in it because the first number is 1. Punch it in your calculator. I'm looking at mine. Looks like I might cross at -1, so I'm going to try the -1. The key here is all the zeros, so I'm going to try the synthetic. Remember, you have to prove that something is a zero, so do synthetic here, multiply and add. Let's go through. It's looking good so far. So there's one of them. Also looking at my calculator, it looks like it crosses 4x or something, might be 4, so I'm going to try that. And really all I'm trying to do is break this down where there's 3 numbers left at the bottom of my division, because once that happens, I can solve any quadratic, and you can too. There it is right there. So 2 of my zeros are going to be -1 and 4. That leaves me with an x squared minus 3x minus 1. So I'm just going to solve that using x equals -b, which would be +3 plus my square root, b squared minus 4ac all over 2a, which is 2 times 1. So I'm running out of room here, but my solutions are going to be, my zeros are going to be -1, 4, and 3 plus or minus square root of 5 all over 2. And that counts as 2 of them. Number 2 says use Descartes' rule of signs to have positive and negatives. It can have, I'm going to do all 3. I'm going to do positive, negatives, and imaginary, because it's that much more fun to do that. Positive, just count sign changes. There's 1, there's 2, there's 3 sign changes, which means there's 3 or 1 positive. There's only 3 altogether, remember. Now, to find out how many odds there are, let's change the signs of the odd exponents, make that -2x cubed, make it a -4x. And when I do that, there are no sign changes. So technically, that's your answer. 3 or 1 positive, no negative. If you want to fill out the imaginary, if there's 3 positive and 0 negative, that means there's also no imaginary because there's 3 altogether. If there's 1 positive and no negative, that means there must be 2 imaginary because there must be 3 altogether. Number 3, show that A and B are upper and lower bounds. I forgot to put what A and B are. Let's write those down right quick. A is going to be something, B is going to be something. Let me find those. All right, A is going to be -3, B is going to be 5. And remember, to show this a lower bound, you do your synthetic division, and with a negative number, it must be a negative number, and your signs on your bottom row here should alternate. So I'm going to bring the 1 down, -3, that's -5, multiply. So far, so good. Still good. Perfect. So that's definitely a lower bound right there because the signs alternated in my final thing. To figure out an upper bound, you got to put a positive number in the box and do the exact same division. And what you're hoping for here is everything on the bottom is a positive number. So 15, 6, so far so good. 32 is going to work perfectly. And that's going to be, I think, 168 right there, which is good. All positive. All positive. Imagine that. Number 4 straight up subtraction. I'm going to subtract the real parts, 3 minus 7, that's -4. I'm going to subtract the imaginary parts, -8i minus -9i, which is really plus 9i, which is just plus I. Didn't do any work there, I hope it's okay. Number 5 is FOIL, so I'm going first. Outer is -72i, inside is -49i. Last is positive, 7 times 18. Everybody knows that is 7 times 18 is probably something like, I don't know, 126. But an I squared. Now, 2 things you can do here. You need to combine your 72 and 49, which I'm pretty sure gives you like -121i. This I squared makes that a -126. I'm doing 28 minus 126. Should give me like -98, and it does. So right there is your final deal there. On number 6, I to the 98th power. That's really we'll use I squared every time to break it down. I squared to the 49th. Remember, I squared is really -1, and because it's an odd power, it's going to stay -1. And there you go. Number 7 is going to take a second. When you divide with complex numbers, you got to multiply by the conjugate of the denominator. Conjugate of 2 plus 3i is 2 minus 3i. So in my denominator is the easy part. Just 2 times 2 is 4, 3i and 3i is -9i squared. So what I get done with the denominator right there, that's 13, because the I squared makes it a plus 9. My numerator, I'm actually going to do FOIL here. I got first, outer, inner, and last. So That's going to be negative 15. 6 minus 15 is negative 9. And if I add the two i's in the middle, it's negative 19i. And there's that one. Number 8, solve. Probably going to solve this and get an imaginary answer, I'm assuming. Let's check it out and see. I'm going to do complete the square because the 2's even. All right, so I'm going to take half of 2, which is 1, square it. That's also 1, plus 1 on both sides. Over here, it's x plus 1 squared. Over here, it's negative 4. Take the square root of each side. The left-hand side, the square just goes away. Right-hand side, plus or minus. Because it's a negative square root, take an I out, then take the square root of 4, which is 2i. Let's move the 1 to the other side. Put it in front of the plus or minus sign. There you have it. Next page. Number 9, factor it completely, find all its zeros. Now, okay, so this is the first one right there. That's just factoring cubes. Okay, so I'm going to say x minus 3, x squared plus 3x plus 9. We've been doing that a long time. But it says completely and find all of its zeros. So one of the zeros is going to be 3. All right, that comes from right here. The other zero is going to come out of here. So I'm going to go to the side somewhere and, well, let's just do a quadratic up here. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, now, you're going to get an answer similar to this. Every time you do a cubic and you have to solve the second part, you're going to get some kind of answer like this one. And inside there, when I do the stuff inside the radical, it's going to, if you look at that, that's 9 minus 4 nines. That's negative 3 nines. I hope that makes sense. That's negative 3 nines. So the square root of 9 is 3. But because it's negative inside, you got to take out an I. And it was 3 nines, so it leaves a 3 inside. That may have been a lot right there. If not, just work it out. Inside, 4 times 9 is 30. I would really get a negative 27 inside. How about that? So I really broke down 27 and took an I out right there. That's all that happened. So there's my zeros. To factor completely then, it's going to look weird. You have to do x minus 3. You would do x minus negative 3 plus 3i on 3 over 2. And you'd also do x minus negative 3i minus 3i on 3 over 2. That's what the factored form looks like. Number 10, difference of squares here. This one probably going to work out just a tad bit easier. If I factor that, 625 has a square root, and it's 25. So I get x squared plus 25, x squared minus 25 when I do difference of squares. Now the beauty of that is the second x squared minus 25, that's also difference of squares. So I can keep breaking that down, x plus 5, x minus 5, which means 2 of my zeros are positive and negative 5. I need the 2 zeros out of here, so again, take it somewhere. Well, let's just do this. X squared plus 25 equals 0. Just move the 25 over. Be negative. Take the square root. You get plus or minus 5i. So my other 2 zeros are plus or minus 5i. So my completely factored form is going to be x plus 5, x minus 5, x plus 5i. That's a terrible plus sign. And x minus 5i. And there you have it. Number 11, find all the zeros of p and factor completely. So again, I'm looking at that like, you know what? I could punch that in. I can make a list, but I really think that's quadratic form. I really think I can go x squared minus 2 and x squared plus 1 and just kind of factor that thing, which it asked me for anyway. X squared minus 2, I can find those zeros really easily. I can bring that over here. X squared minus 2 is 0. Move the 2 over. Take the square root. You get plus or minus square root of 2. So there's 2 of them. The other 2 are going to come from the x squared plus 1 of this. I didn't have to go, even if I looked at the graph, I'm not going to see those anyway. So sometimes you kind of got to find another way. That's plus or minus I. Then it does, so that's the A part. The B part says factor completely, so you just take your zeros and go like x minus square root of 2, x plus the square root of 2, x minus I, x plus I, and there's your B part. Number 12, sketch that graph. This looks a lot like the one that was on last week's test. Got to factor. You got to prove where your zeros are. Don't forget to do this. Show your factors. You must show your factors to get this one right. So please make sure you do that. Factor what's in the parentheses, x minus 2, x minus 1. So my zeros are at 0, 2, and 1. That's really close together right there. It was a 4th degree at first, and so it was even and positive, so both ends go up. This bounces off the 0, goes back down, goes back up, and there you have it. 13, use synthetic substitution to find p of negative 2. Remember, that's just and remainder theorem. That's the hint. The remainder theorem. Your answer is your remainder. Okay, so I'm going to put negative 2 in the box. I'm going to go 2, 1, negative 4, negative 3. Bring the 2 down. That's negative 4, negative 3, 6, 2, negative 4, get negative 7. So the way you write your answer, if you were to plug in negative 2 in for all these x's, you would get negative 7 when you worked it out. That's what I want you to do. Last one, finally, number 14. Express that in standard form. Identify the vertex and its x and y-intercepts. First of all, the y-intercept is 3. Remember, if you put in 0 for x's, you get the y-intercept. Now, standard form is going to be a doozy on the, well, it's not too bad. The one on your test, though, you better really look at this. Okay, so factor out the 2. No matter what's in the middle, you factor out the 2. You have to factor out whatever's in front of your x squared every time. Okay, so that's what I'm getting when I factor it out. Leave the 3 alone on the outside. Complete the square. Half of 2 is 1. 1 squared is 1. Looks like a 1. It's not a 1. It's really 1 times 2, which is 2. So I'm going to put a minus 2 out there. So my standard form is going to look like this. And what standard form is good for, I know the vertex just by looking. The vertex is the opposite of what's inside, exactly what's outside. There's my vertex. All I'll have left is the x-intercept. The way you find the x-intercept, you put 0 in for the y. So I'm going to take the 1 and move it over. Negative 1 equals 2 times x plus 1 squared. I divide by 2. I'm done right here. There's nothing I can square and get negative 1/2, which what that tells me is there's no x-intercept on this one. So I'm going to put NP, or there's not one, or whatever you want to put this whole thing. There is no x-intercept. All right. Hope that helps. Study hard. Come see me tomorrow if you need to. See you then.